So let's take a look at another example here to continue to try to practice this concept of taking the derivative implicitly of a given equation. So here I'm going to be working with the equation sine of x plus y is equal to y squared times the cosine of x. And this is becoming more and more complicated. So let's see how we would start with this. I want to find again the first derivative of y with respect to x. So that means I'm going to take the derivative of both sides here with respect to x. And remember, I'm going to treat y like it's a bunch of stuff, right? It's a big formula with a bunch of x's in it. Okay, so on the left side here, I'll recognize that I have the derivative of sine of a whole bunch of stuff. So I'm going to need the chain rule automatically to take the derivative over here. So I'm going to start by doing cosine of stuff, and then look at the stuff. Is it just an x? No, it's a x plus a y, or an x plus a whole bunch more stuff. So I'm going to need to follow up with the derivative of the inside. So the derivative of x is just 1, and the derivative of my y stuff, I don't really know. So I'm just going to have to call that dy dx. All right, so that side's done. Now I got to look over here. But notice, over here, I have a bunch of stuff being squared, and then times something else. I'm going to need the product rule. So let's start by taking the derivative of our y squared. That is, I want to take the derivative of mystery stuff squared. So that requires chain rule. I'm going to do 2 stuff to the first, multiply by the derivative of the stuff. Then I leave the cosine alone, and put my plus sign down because I've only done half of the product rule so far. Now I can leave my y squared alone, and I'll take the derivative of cosine. Remember, cosine's derivative is negative sine, and just to make sure that I don't accidentally miswrite this, I'm going to go ahead and take that negative here, and I'm just going to put it out in front. There we go. Well, now I can go ahead and I can see that I guess I just need to solve for dy dx. Now, it may be a little bit tricky at first to see how exactly I'm going to do this, because right now I don't even have a term on the left side that kind of contains dy dx. I have like a factor, right? I have something multiplied to something else that contains dy dx. So what I'm going to go ahead and do over here to make this easier, to get all the dy dx's on one side, is I'm going to distribute this cosine. Notice that when I do this, I'm going to get a cosine of x plus y times the 1. And then I'll get another cosine of x plus y, but times the dy dx. So now, when I compare this to what I'm working with on the other side, I can see that here's a term with dy dx, there's a term with dy dx. And I can group those and get them all on the same side. Now remember, it doesn't matter what side you push things towards. I'm going to push my stuff towards the left side. So I'm going to get a cosine of x plus y dy dx. I'm going to get a minus a 2y dy dx cosine of x. And then on the other side, I'm going to get a minus y squared sine of x and a minus cosine of x plus y. All right, so I moved everything over. Well, now I can go ahead, I can factor out my dy dx, writing down what I'm left with. I have all of this stuff. Pretty messy looking. And of course, on the other side, there's not much I can do with the stuff that's over here, nothing to really be combined. So I just kind of have to rewrite it all out. But now that I have this, it's pretty easy for me to go ahead and just say that I'm going to divide everything in these brackets over to the other side, and that will leave me with what dy dx is equal to, which would be a negative y squared sine of x minus cosine of x plus y, and then over a cosine of x plus y minus a 2y cosine of x. There it is. That's as simple as I can make it. Now, if you happen to have tried to move the dy dx to the other side, that's, again, totally okay. There's nothing wrong with doing that. And the only difference that you would have is, again, you could see what that result would be by multiplying what I have here by -1 on top and -1 on bottom, and that would produce the exact same result. So it's just really important here to note that I have to be careful again about when product rules are popping up, when chain rules are popping up, and also that sometimes when I'm going to be solving for the value of dy dx, I might have some algebra to do. You'll notice that if I was to kind of break this problem down, I can see that pretty much all of these steps down here are really just algebra steps, and it's only these first 2 steps up here that have anything to do with calculus. So most of our work right now in implicit differentiation is actually algebra. Right? It's a lot of algebra work. And so you want to make sure that you're aware of what sorts of topics you're struggling with. Are you struggling with a calculus idea or an algebra idea? Because that might give you a sense of what things you might need to go back and review, whether that's calculus notes, or you might want to go back and look up something about, distributing or solving for a variable or things like that. Of course, if you have questions, let me know.